Hello, in this lecture we will find the area of the green shape. In the drawing we have triangle ABC. We know that angle BAC equals to 60 degrees. This angle equals to 60 degrees. We also know that BF equal to CF. BF equal to CF equal to DF, that equal to EF. Okay, BF equal to EF equal to DF equal to EF. And we also know that the area of triangle BDF, this triangle, is equal to 8 square units, and the area of triangle FEC equals to 15 square units. And we want to find out the area of the green shape ADFE. Okay, so first of all we will define angle ABC as B, and we will define angle ACB as C. Okay, and we know that the sum of the angles in any triangle equals to 180 degrees. So actually the sum of the angles in triangle, the big triangle ABC, equals to 180 degrees. That is to say 60 degrees. Angle A that equals to 60 degrees plus angle B plus angle C of triangle ABC must be equal to 180 degrees. Okay, so actually equation number 1 states that the sum of the areas in triangle, the sum of the angles in triangle ABC equals to 180 degrees. That is to say angle A plus angle B plus angle C must be equal to 180 degrees. From equation number 1 we will subtract 60 degrees, and we will get that angle B plus angle C equals to 180 degrees. Okay? Angle B plus angle C equals to 180 degrees. Okay? And in triangle BDF, we know that BF equals to DF, and we have a rule, I will call it rule number 1. Rule number 1 states that in front of equal sides in the triangle there are equal angles. In front of equal sides in the triangle there are equal angles. will read rule number 1 again. Rule number 1 states that in front of equal sides in the triangle there are equal angles. So actually in triangle BDF, this triangle BDF, we know that side BF of the triangle BDF equals to side DF of this triangle. Those two sides, BF equals to DF. So according to rule number 1, in front of equal sides in the triangle there are equal angles. So we have in front of side DF angle beta. So in front of BF it must be equal angle because of the fact that BF equals to DF. Those two angles that are located in front of equal sides must also be equal to each other. Therefore, if this angle is beta, then this angle must be also equal to beta, according to rule number 1 that states that in front of equal sides in the triangle there are equal angles. So those two sides are equal to each other, BF equals to DF. Therefore, in front of equal sides in the triangle there are equal angles. Therefore, the angles that are located in front of those equal sides are also must be equal to each other. We have angle beta in front of DF. Therefore, in front of BF that equals to DF, there must be also angle beta, because in front of equal sides there are equal angles. So the angles that are located in front of equal sides must be also equal to each other. That is to say, if this angle is beta, this angle must be also equal to beta. And the same thing we can say about triangle FEC. In triangle FEC, we know that FC equals to FE. FC equals to FE. So in front of those two sides that are equal to each other, there must be also equal angles. So in front of FE we have angle C. Therefore, in front of FC that equals to FE there must be also equal angles. So if in front of FE we have angle C, therefore in front of FC there must be also equal angle. That is to say, those two angles that are located in front of equal sides also must be equal to each other. So if this angle is C, this angle must be equal also to C, because of the fact that in front of equal sides there are equal angles. We have here two equal sides, therefore in front of those two equal sides there are equal angles. So if this angle is C, those two angles are in front of equal sides. So if this angle is C, this angle must be also equal to C, according to rule number 1 that states that in front of equal sides there are equal angles. Okay, so in front of FC we have C. So in front of EF, we have angle C in front of FC that equals to EF, there will be also the same angle, that is to say, there must be also angle C. So those two angles are equal to each other, they are equal to C. Okay, so in the next step, so according to rule number 1, angle FEC must be also equal to C. Okay, angle FEC, this angle must be also equal to C. Angle FEC must be also equal to C. Okay, and in the next step, we will define angle BFD, this angle is P, and we will define angle EFC as Q. Okay, so we know that the sum of the angles in any triangle is 180 degrees, and especially in triangle BDF, the sum of the angles equals to 180 degrees, that is to say, beta plus P, angle beta plus angle beta plus angle P equals to 180 degrees. Okay, in triangle BDF, the sum of the angles equals to 180 degrees. Okay, so beta plus P equals to 180 degrees. Beta plus beta is 2 beta. 2 beta plus P equals to 180 degrees. Okay, from this equality we can subtract 2b, and we will get that P equals to 180 degrees minus 2b. Okay, angle P equals to 180 degrees minus 2 times b. And we also know that the sum of the angles in triangle FEC equals to 180 degrees. So the sum of the angles in triangle FEC equals to 180 degrees. FEC, the sum of the angles in triangle FEC equals to 180 degrees, that is to say, angle C plus angle C plus Q equals to 180 degrees. Again, in triangle FEC, the sum of the angles equals to 180 degrees. So here we have C plus C is 2C, 2C plus Q equals to 180 degrees. So C plus Q equals to 180 degrees. Again, in triangle FEC, the sum of the angles equals to 180 degrees. From this equality, we will subtract 2C, and we will get that angle Q equals to 180 degrees minus 2C. And we also found out that angle P equals to 180 degrees minus 2B. Okay, Q equals to 180 degrees minus 2C, and P equals to 180 degrees minus 2B. So Q plus P will be equal to 180 degrees plus 180 degrees is 360 degrees minus 2C minus 2B, or Q plus P equals to 360 degrees minus, we will take minus 2 as a common factor of this expression. In the brackets, what is left is C plus B. Okay, so we got that Q plus P equals to 360 degrees minus 2 times C plus B. But we have already found out in equation number 1, we know that C plus B equals to 180 degrees. Equation number 1 states that C plus B equals to 180 degrees, so we can substitute C plus B in this equality by 180 degrees. Okay, here, so we will get that Q plus P this will be equation number 2. Q plus P equals to 360 degrees minus 2 times C plus B is 180 degrees according to equation number 1. So Q plus P equals to 360 degrees. 2 times 180 degrees is 240, and 360 degrees minus 240 degrees is 180 degrees. Okay, so we got that we have equation number 1 that states that A plus B or C plus B equals to 180 degrees. And the equation number 2 states that Q plus P also equals to 180 degrees. Okay, so we have 2 equations. C plus B equals to 180 degrees, and Q plus P also equals to 180 degrees. Okay, so what is the value of angle DFE? The value of angle DFE, the value of this angle, according to the rule that the sum of the angles on a straight line equals to 180 degrees. BC is a straight line, so the sum of the angles on BC equals to 180 degrees. So actually we have angle P plus angle Q plus angle DFE, this angle, equals to 180 degrees according to the rule number 2. Rule number 2 states that the sum of the angles on a straight line equals to 180 degrees. The sum of the angles on a straight line is equal to 180 degrees. So I will read rule number 2 again. Rule number 2 states that the sum of the angles on a straight line is equal to 180 degrees. Therefore, according to rule number 2, the sum of the angles on the straight line BC equals to 180 degrees. That is to say, P plus Q plus angle DFE equals to 180 degrees. P plus Q plus the size of angle DFE equals to 180 degrees, according to rule number 2. Okay? But we have already found out that P plus Q equals to 180 degrees. We have already found out that P plus Q equals to 180 degrees. According to equation number 2, P plus Q equals to 180 degrees. So we can substitute P plus Q by 180 degrees. And we will get that 180 degrees plus angle DFE equals to 180 degrees. Okay, we substituted P plus Q in this equality by 180 degrees, because according to equation number 2, Q plus P equals to 180 degrees. So we got that 180 degrees equals 180 degrees plus angle DFE equals to 180 degrees. Here we will subtract 180 degrees from this equality, and we will get that the size of angle DFE equals to 180 degrees minus 120 degrees is 60 degrees. So we found out that angle DFE equals to 60 degrees. Okay, this angle equals to 60 degrees. Okay, so in the next step we will join together by a straight line points D and E. We'll join together by a straight line points D and E. And according to rule number 1, if we focus on triangle DFE, in triangle DFE, we know that in triangle DFE, side DF equals to side EF. DF equals to EF. Okay, again, in triangle DFE, it is given us the question that side DF of triangle DFE equals to side EF. So according to rule number 1, in front of equal sides in the triangle there are equal angles. So in front of side FC we have angle, this angle that is y, for example, we'll name it as angle y. Then in front of side DF that equals to side FE, we will have also the same angle, because of the fact that in front of equal sides in the triangle there are equal angles. So if here we have angle y, then here we will also have angle y. Okay, so we have here two equal sides in triangle DFE. Therefore, in front of those two equal sides there will be equal angles. Those two angles must be also equal to each other according to rule number 1. So if this angle is y, this angle also must be equal to y. And we know that the sum of the angles in triangle DFE must be equal to 180 degrees. So actually 60 degrees plus angle y must be equal to 180 degrees. 60 degrees plus angle y plus angle y must be equal to 180 degrees. Okay, in triangle DFE, the sum of the angles is equal to 180 degrees. That is to say 60 degrees plus y equals to 180 degrees. Here y plus y is 2y, and we will subtract 60 degrees from this equality, and we will get that 2y equals to 180 degrees. So here we will divide this equality by 2, and we will get that y equals to 180 degrees over 2 is 60. So we found out that angle y equals to 60 degrees. So therefore, triangle DFE is an equilateral triangle. Okay, so here angle y equals to 60 degrees, and here angle y equals to 60 degrees. Therefore, triangle DFE is an equilateral triangle. That is to say, all the sides of triangle DFE are equal to each other. So this also, side DE equals to side DF equals to side EF. Okay, so if we define BF as X, then BF equals to FC. FC also will be X, and also DF that equals to BF also will be equal to X, and also FC that equals to EF also will be equal to X, and also DE will be equal to X. So all the sides here are equal to each other. BF equals to FC equals to DF equals to EF equals to DE, and all the sides are equal to X according to our definition. Okay? So, what is the value of this angle? We know that the sum of the angles along a straight line are equal to 180 degrees. So AB is a straight line. Therefore, the sum of the angles is equal to 180 degrees. So actually 60 degrees plus angle B plus we'll define this angle plus SZ plus Z equals to 180 degrees. Again, the sum of the angles on the straight line AB equals to 180 degrees. That is to say, angle B plus 60 degrees plus Z equals to 180 degrees, according to the rule that states that the sum of the angles on the straight line, rule number 2, is equals to 180 degrees. So here we will subtract 60 degrees from this equality, and we will get that B plus Z equals to 180 degrees. We will subtract B from this equality, and we will get that angle Z equals to 180 degrees minus B. Okay, Z equals to 180 degrees minus B. But we also found out that, according to equation number 1, that angle B plus angle C equals to 180 degrees. So here we will subtract from equation number 1 B, and we will get that C equals to 180 degrees minus B. That is to say, we have here C equals to 180 degrees minus B. So here we have 180 degrees minus B. So from those two equalities, we can get that angle Z equals to C. Okay? Because 180 degrees equals to 180 degrees minus B equals to C. Okay, we have here equation number 1 that says that C equals to 180 degrees minus B. So 180 degrees minus B equals to C. From this equality, we can derive that Z equals to C. Z equals to C. Z equals to C. So actually, here, this angle ADE, equals to C. Okay, and the same thing we can say about the straight line AC. The sum of the angles on the straight line AC is equal to 180 degrees. That is to say, angle AEC, this angle AEC, plus 60 degrees plus C equals to 180 degrees according to rule number 2. Okay, according to rule number 2, the sum of the angles on a straight line equals to 180 degrees. Therefore, angle AEC plus 60 degrees plus C must be equal to 180 degrees. So we will subtract 60 degrees from this equality, and we will get that angle AEC equals to 180 degrees. We'll subtract also C minus C. Okay, we subtracted 60 degrees and also C from this equality, and we found out that angle AEC, this angle equals to 180 degrees minus C. But we have equation number 1 that states that B plus C equals to 180 degrees. So, from equation number 1, if we subtract C from equation number 1, we will get that B equals to 180 degrees minus C. So here we have 180 degrees minus C equals to B. So 180 degrees minus C equals to B. According to equation number 1, 180 degrees minus C equals to B. 180 degrees minus C equals to B. So we found out that angle AEB, AEC, angle AEC, from this equality, we can derive that angle AEC equals to B. Angle AEC equals to B. Okay, angle AEC equals to B. Okay, so we found all the angles in triangle ADE. As you can see, in triangle ADE, we have angles that are equal to 60 degrees to B and C. And in triangle ABC, we also have angles that equal to 60 degrees, angle B and angle C. So we can see from it that triangle ADE is similar to triangle ABE. Okay, so we will focus on triangles ADE, the small triangle, triangle ADE, and the big triangle, triangle ABC. Okay, we will focus on the small triangle ADE and on the big triangle, triangle ABC. Actually, angle ADE, that is actually equals to C on the small triangle, angle ADE equals to angle ACB in the big triangle, and both those two angles are equal to C. Again, angle ADE in the small triangle equals to angle ACB in the big triangle, triangle ABC, and both those two angles are equal to C. And also angle AEB, angle AED in the small triangle, angle AED in the small triangle equals to angle ABC in the big triangle, and both those two angles are equal to B. Okay? Again, angle AED on triangle ADE equals to angle ABC on the big triangle ABC, and both those two angles are equal to B. And we have common angle, this angle A is a common angle. It belongs both to the small triangle, triangle ADE, and angle A equals to, and angle A also belongs to the big triangle, triangle ABC. So angle A equals to angle A. It is a common angle. Angle A equals to angle A. It is a common angle. It belongs to both triangles. Okay, angle angle A equals to angle A. It is a common angle. It belongs to both triangles, to triangle ABC and the big triangle, triangle ABC, and it also belongs to the small triangle, triangle ADE. So we actually proved that all the angles in the big triangle, triangle ABC are equal to all the angles of the three angles of the small triangle, triangle ADE. Therefore, we proved that the big triangle, triangle ABC, is similar to the small triangle, to triangle ADE. ADE, according to angle similarity rule. Okay, we proved that the big triangle, triangle ABC, is similar to the small triangle, triangle ADE, according to angle similarity rule. So from the fact that triangle ADE is similar to triangle ABE, we actually can derive the following equality according to the rule. We have rule number 3. Rule number 3 states that the ratio between the areas of similar triangles between the areas of similar triangles is equal to the square of their corresponding sides. So I will read rule number 3 again. Rule number 3 states that the ratio between the areas of similar triangles is equal to the square of their corresponding sides. Okay, so we will implement rule number 3 in our drawing. We know that triangle ABC is similar to triangle ADE. Therefore, according to rule number 3, the ratio between the area of triangle ABC, that is the way that I mark the sign of area. This means that is the area of triangle ABC over the area of triangle ADE, according to rule number 3, is equal to the ratio to the square of their corresponding sides. So the ratio between the area of triangle ABC to the area of triangle ADE is equal to the ratio between the square of their is equal to the square of their corresponding sides. So we have side the square of triangle, similar triangle BC is BC square over the square of the similar triangle, triangle ADE is DE square. Again, according to rule number 3, the ratio between the areas of those two similar triangles is equal to the ratio between the square of their corresponding sides. That is to say, it equals to BC square over DE square. Okay? But what is the value of BC? The value of BC is x plus x. BC equals to x plus x. BC equals to x plus x. So BC square is 2x square. 2x square. What is the value of DE? According to our definition, DE equals to x. So DE square is x square. So in total, we got that the area of triangle ABC over the area of triangle ADE equals to 2x square over x square. 2x square is 4x square. So it equals to 4x square. 4x square over x square. X square over x square is 1. So in total we will get 4. Because x square is cancelled. X square is cancelled. X square over x square is 1. So the ratio between triangle, the area of triangle ABC over the ratio of triangle ADE equals to 4. Here we can multiply this equality by the area of triangle ADE, and we will get that the area of triangle ABC equals 4 times the area of triangle ADE. Okay? Triangle ABC is 4 times bigger than triangle ADE. Okay? That is the first equation. Triangle ABC equals to 4 times the area of triangle ADE. And what is the area of the shape DBEC? What is the area of the shape DBEC? It is actually quadrilateral DBEC. DBEC. The area of this quadrilateral, it is actually equals to the area of triangle ABC, the big triangle, triangle ABC, minus the small triangle, triangle ADE. Again, the area of this quadrilateral DBEC equals to the area of the big triangle, triangle ABC, minus the area of the small triangle, triangle ADE. Okay, the area of the quadrilateral DBEC equals to the area of triangle ABC minus the area of triangle ADE. But we have already found out that the area of triangle ABC equals 4 times the area of triangle ADE. So we can substitute the area of triangle ABC by 4 times the area of triangle ADE in this equality. We will get that the area of the quadrilateral DBEC equals, we substitute the area of triangle ABC by 4 times the area of triangle AED minus the area of triangle AED. So the area of the quadrilateral DBEC equals to 4 times the area of triangle AED minus 1 time the area of triangle AED equals to 3 times the area of triangle AED. So we actually found out that the area of the quadrilateral DBEC equals to 3 times the area of the small triangle, triangle AED. And we also found out that the area of triangle ABC equals to 4 times the area of triangle, the small triangle, triangle AED. Okay? Again, the area of triangle, the area of the quadrilateral DBEC equals to 3 times the area of triangle AED, and the area of triangle ABC equals 4 times the area of the triangle AED. And we also know, we have a rule that the area of any triangle, if we have triangle ABC, if we have triangle ABC, we know that side AB equals to A units, side AC equals to B units, and the angle between side AB and side AC is theta. Then the area of this triangle, triangle ABC, equals to A times B times sinus theta over 2. That is the area of triangle ABC. Again, the area of triangle ABC equals to A times B times sinus theta over 2. Okay, so actually the area of triangle FEC equals to 15 units. It is given us in the question. And the area of triangle BDF equals to 8 units. but according to the formula that I showed you, according to the formula that I showed you, for the area of the triangle, any triangle, the area of triangle FEC equals to x times sinus q over 2. Okay, x times x, the multiplication of the two sides of triangle EFC times the angle between, sinus the angle between those two sides over 2 times sinus q over 2. Again, the area of triangle FEC equals to x times sinus theta over 2. The area of triangle EFC equals to x times sinus q over 2. And what is the area of triangle DBF? The area of triangle DBF will be equal again to x times sinus p over 2. X times sinus p, the angle between those two sides, over 2. Okay, so that is the area of triangle BDF. So here we have, we can move 2 in the denominator in both sides, so 2 will be cancelled, because we have here actually 2 times x squared sine q over 2 times x squared times sine p equals to 15 over 8. Okay, we got this equality that 2 times x times sine q equals to 2 times x squared times sine q equals to 2 times x squared times sine p, all equals to 15 over 8. So here 2 times x over 2 times x is 1, so it is cancelled. In total we got that sine q over sine p equals to 15 over 8. Sine q over sine p equals to 15 over 8. Okay, we got this equality that sine q over sine p equals to 15 over 8. But from equation number 2 we know that p plus q equals to 180 degrees. We've already found out in equation number 2 that p plus q equals to 180 degrees. So if we subtract from equation number 2 p, we will get that q equals to 180 degrees minus p. Okay, q equals to 180 degrees minus p. So we can subtract from this equality q we can substitute Q by 180 degrees minus P, because Q equals to 180 degrees minus P. So we will do it now. Instead of sinus Q, we will write down sinus 1 sine of 180 degrees minus P over sine P equals to 15 over 8. Okay, again, we actually substituted Q by 180 degrees minus P, and we got this equality. What is the value of sinus 180 degrees minus P? Actually, we have trigonometric identity that states that sine A minus B equals to sine A times cosine B minus sine B times cosine A. Okay, we have this trigonometric identity that states that sine A minus B equals to sine A cosine B minus sine B cosine A. So we will substitute, substitute sinus 180 degrees by using we will use this equality in order to find out the value of sine of 180 degrees minus P. Okay, so sine 180 degrees minus P equals to sine 180 degrees times cosine P minus sine P times cosine 180 degrees. So it is equal to sine 180 degrees minus P. So it is equal, sine 180 degrees is root 3 over 2 times cosine P minus sine P times cosine 180 degrees is minus 1 over 2. Okay, so that is actually the value of sine 180 degrees minus P. Again, we will substitute sine 180 degrees minus P by this expression, and we will get that root 3 over 2 times cosine P over sine P minus 1 over 2 sine P over sine P. Equals to 15 over 8. Okay, so from this equality we substituted sine 180 degrees minus p by this expression, and we got that root 3 over 2 times cosine p over sine p minus is plus. Here we have sine p over sine p is 1, so sine p is cancelled. Minus 1 over 2 is plus 2, so in total we will get that root 3 over 2 and cosine p over sine p is cotangent p, minus 1 over 2 is plus 1 over 2 equals to 15 over 8. Okay, so here we will subtract 1 over 2 from this equality, and cotangent p equals to 1 over tangent p. Cotangent p equals to 1 over tangent p. Again, cotangent p equals to 1 over tangent p. Okay, we have this trigonometric identity that states that cotangent p equals to 1 over tangent p. We will substitute cotangent p by 1 over tangent p. We will get that root 3 over 2 equals to 1 over tangent p, and we will subtract also 1 over 2. 1 over 2 is 4 over 8. 4 over 8, 15 minus 4 is 11. So in total we got that root 3 over 2 times tangent p equals to 11 over 8. Here we will multiply this equality by tangent p, and we will get that 11 over 8 times tangent p equals to root 3 over 2. Okay, we got that 11 over 8 times tangent p equals to root 3 over 4. Here we will multiply this equality by 8, and then we will divide it by 11 in order to get the value of tangent p. We will get that tangent p equals to root 3 times 8 over 4 over 11. So 8 over 4 is 2. So we will get that tangent p equals to 2 times root 3 over 11. Okay, tangent P equals to 2 times root 3 over 11. Here it is actually root 3 over 2, root 3 over 2, so it is root 3 over 2, and 4 times 2 is 8 over 2 is 4, so in total we got that tangent P equals to 4 times root 3 over 11. So actually tangents is the relationship between the sides in a right triangle. So we have here so actually according to what we got here, the side in front of angle P is 4 times root 3 and the side near angle P is 11. So according to the Pythagorean theorem, the hypotenuse of this triangle will be equal to root of 4 times root 3 square plus 11 square. Okay, so actually sine P equals to 4 over root 3 over root of 4 times root 3 square is 48. 48 plus 121 is 169. So actually sine P equals to 4 times root 3 over 13. So we found out the value of sine P. Sine P equals to, again I write it here, that sine P equals to 4 times root 3 over 13. Okay, so here we know that the area of triangle DBF equals to 8 units. What is the formula for the area? So the area of triangle DBC equals to x squared times sine P. over 2, and it equals to 8. Again, the area of triangle DBF, the area of triangle DBF equals to the multiplication of its two sides times sine p over 2. But we have already found out the value of sine p, so we can substitute sine p in this equality by the value of sine p. So here we will get that x square sine p equals to 4 times root 3 over 13 over 2 equals to 8. So x square 2 times root 3 over 13 equals to 8. So here we'll divide this equality by 2 and we will get that root 3 times x squared over 13 equals to 4. Okay. So we got actually the value of x squared. X squared equals to 13 times 4 is 52 over root 3. So we found out that x squared equals to 52 over root 3. And what is the area of the equilateral triangle DEF? The area of triangle DEF, the equilateral triangle DEF equals to x squared, all the sides of the triangle equals to x squared times sine 60, that is root 3 over 2, all divided by 2. So that is the area of the equilateral triangle DEF, according to the special formula that I presented to you. So actually the area of the equilateral triangle DEF equals to root 3 times x squared over 4. Again, the area of the equilateral triangle DEF equals to root 3 times x squared over 4. But we have already found out the value of x squared, so we can substitute x squared in this equality by the value of x squared. Okay, so the area of triangle DEF equals to x squared is 52 over root 3 times root 3 over 4. Okay, so the area of triangle the equilateral triangle DEF equals to 52 over 4, root 3 over root 3 is 1. It's cancelled. 52 over 4 is 13. 13. So the area of the equilateral triangle DEF equals to 13 square units. Okay, so the area of the equilateral triangle DEF equals to 13 units. Okay, now we actually know we can calculate the area of the quadrilateral DBEC. The area of quadrilateral DBEC again, the area of the quadrilateral DBEC equals to 8 plus 13 plus 15. It consists, the quadrilateral DBEC consists of 3 triangles. Okay, so the sum of the areas of the 3 triangles equals to the area of the quadrilateral DBEC. 8 plus 13 is 21, 21 plus 15 is 36. We found out that the area of the quadrilateral DBEC equals to 36 square units. Okay, again, we found out that the area of the quadrilateral DBEC equals to 36 square units, but we have already found out that the area of quadrilateral DBEC equals 3 times the area of triangle ADE. 3 times the area of triangle ADE. Again, the area of quadrilateral DBE equals to 3 times the area of triangle ADE. And we know that the area of quadrilateral DBEC equals to 36 square units. So here we can divide this equality by 3 and we will get that the area of triangle ADE equals to 36 over 3 is 12 square units. Okay, 12 square units. So the area of triangle ADE equals to 12 square units, and the area of the green shape, the area of quadrilateral ADFE, it consists of 2 triangles. It consists of the equilateral triangle DFE that equals to 13 square units, and it also consists of the triangle ADE that equals to 12 units. So the area of quadrilateral ADEC, the green shape, the area of ADEF, the green shape, equals to 12 plus 13, that is actually 25 square units. Okay, so the final answer of the question is that the area of the green shape, the quadrilateral ADEF, equals to 25 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green shape, the green quadrilateral ADFE. Okay, and we know that the angle BAC equals to 60 degrees, and we know that BF equals to CF equals to DF equals to EF, and we also know that the area of triangle DBF equals to 8 square units, and the area of triangle EFC equals to 15 square units. And we want to find out the area of the green shape, the green quadrilateral ADFE. Okay, so first of all, we defined angle ABC as B, we defined angle ACB as C, and we know that the sum of the angles in any triangle is equal to 180 degrees. And therefore the sum of the angles in the big triangle ABC equals to 180 degrees. Okay, again, the sum of the angles in triangle ABC equals to 180 degrees. That is to say 60 degrees plus B plus C equals to 180 degrees. Okay, equation number 1 states that 60 degrees plus B plus C equals to 180 degrees. We subtracted 60 degrees from equation number 1, and we got that angle B plus angle C equals to 180 degrees. And we have rule number 1 that states that in front of equal sides in the triangle there are equal angles. Okay, so in triangle BDF we have two sides, this triangle, two sides that are equal to each other. BF equals to DF. So in front of BF we have angle beta. So in front of X we must have the same angle, because in front of equal sides there are equal angles. So those two angles must be equal to each other according to rule number 1. And if this angle is beta, then this angle also must be equal to beta. Okay? And according to rule number 1. And we also have in triangle FEC, we have two sides that are equal to each other. FE equals to FC. Those two sides are equal to each other. And we know that according to our definition, in front of side FE, we have angle C. So in front of side FC, we must have the same size of angle. Therefore, those two angles that are located in front of equal sides must be also equal to each other. So if this angle is C, this angle must be equal also to C. Okay? So then we focus on triangle BDF. We know that the sum of the angles in triangle BDF equals to 180 degrees. That is to say B plus B plus P equals to 180 degrees. B plus B plus P equals to 180 degrees in triangle DBF. We subtracted 2B from this equality and we got the value of P. P equals to 180 degrees minus B. And then we focused on triangle FEC. Again, in this triangle also, the sum of the angles are equal to 180 degrees. That is to say, C plus Q equals to 180 degrees, or 2C plus Q equals to 180 degrees. We subtracted 2C from this equality, and we got that Q equals to 180 degrees minus C. And we also found out that P equals to 180 degrees minus 2B. Here we added those two equalities together. Q plus P equals to 180 degrees plus 180 degrees is 360 degrees. We have here minus 2C minus 2B. Then we took a common factor of minus 2 from this expression, and we got that Q plus P equals to 360 degrees minus 2 times C plus B. But we have already found out that C plus B equals to 180 degrees, so we can substitute C plus B in this equality by 180 degrees. We substituted C plus B by 180 degrees, and we got that the value of Q plus P is 180 degrees. So C plus B equals to 180 degrees according to equation number 1, and according to equation number 2 we found out that also Q plus P equals to 180 degrees. Okay, so then the angle DFC. What is the value of angle DFC? We have rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. So BC is a straight line, therefore the sum of the angles on the straight line BC equals to 180 degrees. So angle P plus angle Q plus angle DFE must be equal to 180 degrees according to rule number 2. Okay? Angle P plus angle Q plus angle DFE plus this angle must be equal to 180 degrees. So here we know that P plus Q equals to 180 degrees according to equation number 2. Okay, so we substituted P plus Q by 180 degrees. We got that 180 degrees plus angle DFE equals to 180 degrees. We subtracted 180 degrees from this equality, and we got the value of angle DFE that equals to 60 degrees. So this angle equals to 60 degrees. Okay, then we connected together points D and E by a straight line. We know that DF equals to EF, and we have rule number 1 that states that in front of equal angles in front of equal sides there are equal angles. So DF equals to EF, and in front of those two equal sides there must be equal angles. So if we define this angle as y, this angle must be also equal to y according to rule number 2. Okay, so, and we also know that the sum of the angles in triangle DFE equals to 180 degrees. So we have angle 60 degrees, this angle is 60 degrees, this angle is y, and this angle is also y. So according to the law that the sum of the angles in the triangle equals to 180 degrees, 60 degrees plus y must be equal to 180 degrees in triangle DFE. Okay, here we subtracted 60 degrees from this equality. and we got that 2y equals to 180 degrees. Then we divided this equality by 2, and we found that y equals to 60 degrees. So here we have 60 degrees, it is y, and y here equals to 60 degrees. So actually we found out that triangle DFE is an equilateral triangle. Okay, so that is to say all its sides are equal to each other. So if this side is x, this side is x, DE also must be equal to x. Okay, then we know also that the sum of the angles on a straight line equals to 180 degrees. So the sum of the angles on the straight line AB equals to 180 degrees. That is to say, beta plus 60 degrees plus this angle, that is Z, we defined it as Z, must be equal to 180 degrees. Again, according to the rule that the sum of the angles on a straight line equals to 180 degrees, 60 degrees plus B plus angle Z must be equal to 180 degrees. We subtracted 60 degrees from this equality, and we got that B plus Z equals to 180 degrees. We subtracted B from this equality, and we got that Z equals to 180 degrees minus B. But we have a question number 1 that says that B plus C equals to 180 degrees. So here we subtracted beta from equation number 1, and we got that C equals to 180 degrees minus B. So here 180 degrees minus B equals to C. So angle Z equals to C. So this angle Z equals to C. And we did the same rule, we implemented the same rule here that states that the sum AC is a straight line, and we know that the sum of the angles on a straight line equals to 180 degrees. So C, angle C plus 60 degrees plus angle AED must be equal to 180 degrees. Again, angle on the straight line AC, the sum of the angles equals to 180 degrees. So the sum of the angles on the straight line AC is angle AC plus 60 degrees plus C equals to 180 degrees. Okay, so here we subtracted 60 degrees from this equality, and we subtracted also C, and we got that angle AEC equals to 180 degrees minus C. We know that B plus C equals to 180 degrees, and if we subtract from this equation number 1 C, we will get that B equals to 180 degrees minus C. So we have here angle AC equals to 180 degrees minus C, and according to equation number 1, B 180 degrees minus C equals to B. So here we can write down that 180 degrees minus C equals to B, and from this equality we can derive that angle AEC equals to B. Okay, angle AEC equals to B. So we actually have here the small triangle, triangle ADE, that has three angles of 60 degrees, C and B, and triangle ABC also have the same angles, angles that are equals to 60 degrees to B and C. So we actually can prove that the small triangle, triangle ADE, is similar to the big triangle, triangle ABC. Okay, in triangle ADE and triangle ABC, angle ADE equals to angle ACB equals to C. Angle ADE in the small triangle equals to angle ACB, and both those two angles are equal to C. Okay, and then we also know that angle AED equals to angle ABC equals to B. Angle AED equals to angle ABC, and both those two angles are equal to B. And the third angle, the third pair of angles, angle A is a common angle. It belongs both to the small triangle, triangle ADE, and angle A equals also angle A belongs also to the big triangle, triangle ABC. So angle A equals to angle A. Okay, angle A equals to angle A. It is a common angle. It belongs to both triangles. So actually, we proved that all three angles of triangle ABC equals to all the three angles of the small triangle, triangle ADE. Therefore, we proved that those two triangles, triangle ADE is similar to triangle ABC according to angle similarity rule. Okay, so from the fact that those two triangles are similar to each other, we can implement rule number 3 that states that the ratio between the areas of similar triangles is equal to the square of their corresponding sides. That is to say, the ratio between the areas of triangle ABC, that is the sign for area, the ratio between the area of triangle ABC over the area of triangle ADE equals to the square of their corresponding sides. Okay, it equals to the square of their corresponding sides. That is to say, to BC square over DE square. And what is the size of BC? BC equals to x plus x. So BC square equals to 2x square. And what is the size of DE? DE equals to x. So DE square is x squared. So in total we got that the ratio between the areas of those two similar triangles equals to 4x squared over x squared is 4. Or we got that the area of triangle ABC is 4 times big than the area of the small triangle, triangle ADE. That is the first equality. And then what is the area of the quadrilateral DBEC? The area of quadrilateral DBEC equals to the area of triangle ABC minus the area of the small triangle ADE. Okay, again, the area of triangle, the equilateral DBEC equals to the area of triangle ABC minus the area of the small triangle, triangle ADE. But we have already found out that the area of triangle ABC is 4 times the area of triangle AD. Okay, so here the area of the quadrilateral DBEC equals to 4 times the area of triangle AED minus 1 times the area of triangle AED, or the area of the quadrilateral DBEC equals to 4 times the area of triangle AED, and we have already found out that the area of triangle ABC equals to 4 times the area of triangle AED. Then we have the formula for the area of any triangle. The area of any triangle equals to A times B times sinus theta over 2. Okay, and we have here two triangles that we know the area of them. So 15 over 8. So 15 is the area of this triangle. And what is actually the formula for the area of this triangle? It equals to, according to the formula that I presented to you, it equals to the multiplication of their sides by sinus the angle of between them over 2. it equals to x times sine times sine q over 2. That is the area of this triangle. And what is the area of this triangle? Triangle DBC. It equals to the multiplication of the sides by each other times the sine of the angle between those two sides. Or it equals actually to x times sine p over 2. Okay, that is the area of this triangle. So here we have 2x square over 2x square is cancelled, and what is left here, that sine q over sine p equals to 15 over 8. Okay, but we know that p plus q equals to 180 degrees according to equation number 2. So q equals to 180 degrees minus p. So we can substitute q in this equality by 180 degrees minus p. Okay, so we substituted q by 180 degrees minus p, and we got that sine 180 degrees minus p over sine p equals to 15 over 8. And in order to calculate the value of sine 180 degrees minus p, we have a trigonometric identity that states that sine a minus b equals to sine a times cosine b minus sine b times cosine a. And we developed this expression according to the trigonometric identity, and we found the value of sine 180 degrees minus p, and we substituted sine 180 degrees minus p by this expression that equals to sine 180 degrees minus p, and we found out that it is actually equals to, okay, we actually substituted sine 180 degrees minus p by this expression, and we found out that tangents p equals to 4 times root 3 over 14, and if we have the value of tangents p, then we can also find out the value of sine p, because the value of sine p equals to the ratio between this side, that is 4 times root 3 over the hypotenuse, and we know the value of the hypotenuse. So we found out the value of sine p. Sine p equals to 4 times root 3 over 13. Okay, sine p equals to 4 times root 3 over 13, and we know that the area of triangle DBF equals to 8 units. Okay, and what is the formula for the area? It is the multiplication of the sides by each other times the sine of the angle between those two sides over 2. Okay, so, or it is actually x squared times sine p, the angle between those two sides are p. So sine p over 2, x squared times sine p over 2, and we know that the area of this triangle equals to 8 square units. So we have already found out that sine p equals to 4 times root 3 over 13. So we can substitute sine p in this equality by 4 times root 3 over 13. We substituted it, and we found out that x squared equals to 52 over root 3. After we found out the value of x squared, we can calculate the area of the equilateral triangle DEF, because it is actually equals to x times sinus 60 over 2 according to the formula that I presented to you. The area of the equilateral triangle equals to x times sine 60 degrees over 2, or the area of triangle DEF equals to root 3 times x squared over 4. But we have already found out that x squared equals to 52 over root 3. So we can substitute x squared in this equality by 52 over root 3. We substituted it and we found out that the area of the equilateral triangle DEF equals to 13 square units. So we know now that the area of the quadrilateral DBEC equals to 8 plus 13 plus 15, that is 36. Okay, we know that the area of the quadrilateral DBEC equals to 36 square units. And we have already found out that the area of the quadrilateral DBEC equals to 3 times the area of triangle ADE. So we know that the area of triangle DBEC, the area of quadrilateral DBEC equals to 36 square units, and it also equals to 3 times the area of triangle ADE. So we can divide this equality by 3, and we found out that the area of triangle ADE equals to 12 units. And the area of the green shape, the area of quadrilateral AEFD, that is the green shape, it actually equals to the area of those two triangles, that is 12 plus 13. 12 plus 13 is 25, so the area of the quadrilateral AEFD equals to 25 square units. Okay, thank you very much.